Hi, welcome to Thermodynamics with me, Eddie Moreira. Thermodynamics is the study of the effects of work, heat, and energy on a system. Thermodynamics is only concerned with large-scale observations. Here are some of the things we are going to cover in my thermodynamics class. This is what we are going to be learning today in my class. Laws of thermodynamics. Laws of water, which include melting, freezing, condensation, and vaporization. Thermal equilibrium. Forming and breaking bonds. And finally, entropy and enthalpy. Enjoy! Laws of thermodynamics. The zero. Two systems are said to be in thermal equilibrium with each other if both are in equilibrium with a third. A equals B and B equals C, then A equals C. First law. First, law of conservation of energy. Second, entropy in the universe is always increasing. Third, no system can reach absolute. If A and C are in thermal equilibrium with B, then A is in thermal equilibrium with C. Practically, this means that all three are at the same temperature and it forms the basis for comparison temperatures. It is so named because it logically precedes the first and second laws of thermodynamics. Equation to find thermal equilibrium: n plus C plus Tf minus T1 equals negative m plus C plus. This is an example of finding the thermal equilibrium. A 12-gram piece of aluminum is at 70 degrees Celsius. It's placed in a beaker that contains 35 grams of 15 degrees Celsius. And the thermal equilibrium comes out to 18.8 degrees Celsius. This makes sense because the hotter object cools the cooler object and the cooler object cools the hotter object. And changes in states of matter. Solid to liquid is melting, liquid to gas vaporization, solid to gas is sublimation, gas to liquid is condensation, liquid to solid is freezing, and finally gas to solid is deposition. Connection to thermal equilibrium. An example is when the ice cube goes into a cup of lemonade. When the ice cube goes into the cup of lemonade, it transfers its energy into the lemonade. At the same time, the lemonade is transferring its energy to the ice cube. Eventually, the ice cube will melt and the lemonade and water will be the same temperature. This process of melting shows how the main goal between the two. The law of conservation of energy. Energy stays constant no matter what. Energy cannot be destroyed but transferred from one form to another. Example is water. Water can be frozen, melted, vaporized, or condensated into solid or gas, but throughout the process of changing states of matter, the energy level stays constant through the experiment. The entropy of the universe never decreases. This is the second law of thermodynamics. Entropy is a thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work, often interpreted as a degree of disorder or randomness in the system. The third law of thermodynamics: no system can reach absolute zero. An object's temperature depends on how much its atoms move. The warmer the object, the faster the atoms move, and vice versa. The system can't reach absolute zero because all the energy would leave the object, and that would not follow the first law of thermodynamics. Enthalpy. Enthalpy has two types of reactions: endothermic and exothermic. Endothermic reaction is when energy is absorbed during an experiment. Exothermic reaction is when energy is released during an experiment. When an exothermic reaction happens, it exerts heat into the air, but when an endothermic reaction happens, the object in which the reaction happens to becomes cold. Delta H is a driving force and it's an increase in entropy. Delta H is enthalpy. Solids are the most ordered, gases are the least ordered. As seen in the diagram, moving to the left, and the increase in entropy means more chaos. Gas is the most chaotic, while solids are the most stable and less moving. Continuation of the rules of enthalpy. The first, negative delta H and positive delta S, result in always spontaneous. Sometimes spontaneous is positive delta S, and negative delta H and negative delta S. And finally, positive delta H and negative delta S result is never spontaneous. Calculating enthalpy. First, we have to use the problem below. Using stoichiometry to convert moles to kilojoules per mole. This is important because without converting the measurement, we cannot get the correct answer and know if the dissolution is exothermic or endothermic. Solve the equation, we get negative 81.96, and the answer is exothermic because the delta H is a negative number, which means it's Bond breaking is an endothermic process. Energy is released when new bonds form. Bond making is an exothermic process. Whether the reaction is endothermic or exothermic depends on the difference between the energy needed to break bonds and the energy released when new bonds form, which is shown in the examples below. Go look at my class and hope you enjoy learning about the amazing world of thermodynamics. Thank you for watching.
Created using Powtoon.